Hello everyone. In the previous session we have seen about Spark, how do we install Spark and what are RDDs and how better is Spark compared to MapReduce, all these things. Now we shall talk about what are various types of operations that are available in Spark. Spark has two types of operations, transformations and actions. What do we mean by transformation? An existing RDD is there, you perform some operations on that and you are changing it into another type of RDD. We call such kind of operations as transformations. One more type of operation in Spark on RDDs is action. What do we mean by action? An RDD is there, you performing some operations on that which will try to give you an output value. So, an existing RDD changed into another RDD, we call it as transformation. An RDD is there, you performed some operation like aggregation, summing up the values. So, we call it as an action and it is trying to give you an output value. So, Spark basically relies on these two types of operations, transformations and actions. So, just quickly look at both the things. Transformation generates a new RDD from an existing one, while an action triggers a computation on RDD and does something with the results. Fine. Actions have immediate effect, transformations do not. Whenever we are learning Spark, we say actions have immediate effect and transformations are lazy. What do we mean by that? I try to explain that with an example. Just go through this example. What are we trying to do in this? You are trying to take text from a text file and you are specifying the input path. So, it will take the entire data from the file and puts it into the variable text. Then what are you specifying? An RDD of string type which contains the values for text dot map of to lowercase. What is the meaning of this one? From the file we have read the content and kept it into the variable text. This RDD, you are specifying whatever content we have read from the file should be converted into lowercase. This is a transformation. An existing data is there from the text file, it should be converted into lowercase. So, you are not changing the content of the file, you are just changing the way it appears, right. So, we are trying to convert the text which we read from the file to lowercase. So, this is a transformation. Then you are specifying for each print the line. Lower, what is the lower? Whatever text we have converted into lowercase, for every line you are trying to print it. This is an action. You want to show the output. Wherever we are showing the output by performing an operation, we call it as an action. Now, unless we specify this action, the transformation will not be taking place. Try to understand, whenever I say please print the lines which are converted into lowercase, unless this control comes to this print line statement, the text which was read from the file will not be transformed into lowercase. So, the transformations in Spark are always called as lazy computation. They are not computed until an action on them is performed. That is how we call them as lazy computed. Then, whenever we are working with the example, I have explained that. So, the map is a transformation, it will not be executed until you are calling the action called printing. Then how do I identify which one is a transformation, which one is an action? See the return type of that. If the return type, one way of telling whether an operation is a transformation or an action is looking at its return type. If the return type is an RDD, then it is a transformation, otherwise it is an action. Just quickly look at the previous example. What are we trying to do in this line? Whatever text we have read from the file, that will be converted into lowercase and you are holding it into the variable called lower. So, in this case, what will be the content of lower? The same data what we have read from the file, but in another format. So here the return type is an RDD. How do you say that? If you see here, value for lower is like a variable of which type? An RDD of data type string. So if the return type is an RDD, it should be considered as a transformation. Here what are we trying to do? We are just trying to print it. So when there is no return type or the return type is not an RDD, it should be considered as an action. And Spark library consists of so many types of operators for transformations, mapping the data, grouping the data, performing aggregations on the data, partitioning the data, repartitioning the data, taking samples out of the data set and joining various RDDs, various types of operations. So Spark has built-in operations for all these categories. And there are also actions which are trying to materialize the RDDs. What do we mean by materialization? We are trying to generate an output of the RDD wherein you are trying to work on statistical functions, trying to take a fixed number of elements from the RDD likewise. So we have various types of transformations and actions which are built into Spark. So I'll just show you some of the examples. I'm taking aggregation. Aggregation is a kind of transformation. Just quickly look at this. The three main transformations for aggregation category which is applied onto an RDD of pairs by their key values are reduce by key, fold by key, aggregate by key. There are three operations: reducing, folding and aggregation. So let us talk about these things. They work slightly in different ways. What is the difference between them? Whenever I have key value pairs, I can apply three types of aggregations: reduce, fold and aggregate. Now, simplest operation we are trying to see is reduce by key, right? So, what will be the input to you? You have a set of key value pairs. We are trying to reduce them by what? Reduce by key. So, what happens? Try to understand with this example. Value pairs of what data type? It is an RDD. Key value is a string. Whatever key you have in this pair, key is a string and value is an integer. And what is the data? You are trying to say, please apply parallelism. Computation should be done in parallel. What is the array I have? The first pair is key is A, value is 3. Second pair, key is A, value 1, B 7, A 5. I just took example of 4 key value pairs. So you have defined an RDD which is consisting of key value pairs. Key is of string type, value is of type integer. Then you are specifying value sums is an RDD again of key is of string type, value is of integer type. Now if you see, the return type is an RDD, sums is of type RDD. What is the operation you are specifying? Pairs dot reduce by key. If you see the operator underscore plus underscore, this should be understood as you are supposed to do the summation based on the key values whenever they are matching, right? So this reduce by key is an aggregation, and how do I say it is a transformation? Whatever it is returning, it is an RDD. Right? Then you are trying to ascertain from the sums dot collect to set triple equal to. I will talk about this triple equal to, whether it is a set with key as A, value is 9, B as key and value is 7 or not. You are asking this Spark engine to ascertain whether this is the output or not. Just to try to see how the operation is executed. What are the key values? What is the function you are calling? Reduce by key. Wherever the key value is matching, it will try to do the operation specified on the values. What is the operation we have specified? Sum it up, right? So, for these three pairs, the key value is A. What is the sum of those values? 3 plus 1 plus 5. 9 is the value. So for key A, what is the summation value we are getting? 9. For key value B, there is no matching one, so it comes as it is. Key is B, value is 7. So you are trying to say, once you finish the operation on the sums variable, ascertain whether it is equal to A with 9, B with 7. Now, what is this triple equal to? You can give double equal to also, which will just to show whether the output that is computed is equal to this set or not. Whenever we are giving triple equal to, that means if at all any failures are there, additional message on those failures should also be shown to you. In such cases, we are supposed to use triple equal to. Then we want to work with the same operation using fold by key. This is the second operation on aggregation. What is the difference between reduce by key, fold by key? Whenever we are working with fold by key, you submit an additional operand 0. What is the meaning of that one? For every value you are trying to work, 0 will always be a match. So what it will do? It will try to do the operation on, for first key value A, what are the matching values you have? 3, 1, 5. So what it will do, for all those values, it will add additionally whatever value you have supplied during fold by key. In my example here, we are submitting 0. So it will try to do 0 plus 3 plus 1 plus 5. And if you just observe, whenever we are trying to work with the values, there is no necessity or there is no guarantee that the values are taken in the order in which you have given. It can compute 3 plus 1 plus 5, or it can compute 3 plus 5 plus 1, or it can compute the other way. It only looks for whether the keys are matching or not. It will not guarantee that the values are always taken in the same order. But whenever you are trying to give fold by key and you are giving 0, addition with 0 or summation with 0 is always the first operation. With what value it is going to add, that cannot be guaranteed, but 0 plus one of the values will be definitely the first operation. Similarly, for second key, there is no matching key, so it will do 0 plus 7 in this example. So using fold by key is not, it's no more or less powerful than using the reduce by key. One more option is there, aggregate by key. What is the difference between aggregate by key? It will try to see the data set as a hash set. The values which are there in the pairs, they will be considered as a hash set. The moment you go for hash set, you can define what is the order of the values, because it takes them in an ascending order. That is how you are trying to take. Then persistence, as I told, whenever we are working with Spark, persistence is the most important concept. What do you mean by persistence? Suppose I have a data set which I have loaded into memory and I have done some transformations or actions, or in general I have performed some operations on them. The data set will be held in a cache memory for future uses, possible future uses. So holding the data set in order to avoid reloading into memory again for future operations is called as persistency. How do we do that? We do this with a method called tuples.cache. The moment you call this method, it will try to put them in the cache memory. Now try to see my example. Tuples.reduce by key a comma b should be taken as math.max of a comma b, and for every value you should be printing that. Whenever you are applying this transformation after finishing the work, if you observe, it will show info, block manager info, added the RDD into which memory location? Fourth location. And if you see, first one is showing fourth location under 0, Second one, fourth location under 1. What is the meaning? My data set, my resulting data set is splitted into 2 splits. First split is stored in 4, 0, 4 underscore 0. Second one is 4 underscore 1. So if it was a huge data set, it was divided into 2 splits. These are the locations for both the splits. It has put them into the cache memory under that location. So for the future applications, I want to work with, see, if you see in the previous example, I was working with max function. Future purpose, I want to use the same data set to work with min function. Do I again load the data from the HDFS or external sources into main memory? No. What it will do, if you see, info block manager found the block under 4 underscore 0 locally, and it is found under, the second split is found under RDD underscore 4 underscore 1 locally. So I did not fetch them from external sources, I have found them locally in the cache memory. So whatever data it is available in the cache memory, it is trying to finish the work and it is giving you the output, right? So persistence helps us not to load the data again and again whenever we are trying to apply multiple operations on same data set. And persistence levels you can define. By default it will go for memory underscore only. What does that mean? Entire data set should be loaded into main memory. What if the memory is not sufficient for holding the data? In such case we go for memory underscore only underscore serialization. Go for serialization of the data, put it in a byte array. Wherever I have bytes available, try to put the data. This is second option. It tries to reduce the garbage collection process also, because we are trying to occupy wherever the locations are empty, we are trying to occupy the byte arrays. By default, it goes for Java regular serialization mechanisms. If you are not happy with the Java serialization mechanism, Spark provides something called as Cairo serialization. So under Cairo serialization, what we will do is, if at all I am working with Java serialization, I need to say implement serializable interface. But when you are working with Cairo serialization, we just set the serialization using this method and we register whatever class we have written into Cairo registrator. The moment you have done this, your class is registered into Cairo serialization and it will take care of serializing your data. And whenever we are working with functions, by default all the functions will be serialized by the Spark context, and even if the file is in local memory also, it will be serialized. If at all there is a file or a function which cannot be serialized, it will be found first in the development process. So this is how Spark works with various types of operations, serialization method, and how does it deal the functions, whether it is serializing them by default, local functions, what it is doing, all these concepts related to Spark. Thank you.